Welcome to the Dobsonian Power Night Sessions. Tonight we have a clear sky finally, and we are watching the sky in real time with a telescope, 12-inch Dobsonian, the King.
The King.
Hello Steve Miller, Marco, Brian Fowler, Charles Paul, Green Cat, John McCary, now there are more people, Andrew, Astro Thieves, Steve Miller, Stars and Night Vision, Antonio Cortez. Antonio Cortez is in the house. Ofra Head, Green Cat, West Coast Twins with the Dobsonian Power.
Dobsonian Power.
Quasar, Mark, Adam, Rao. Greetings to Romania. Now, as I was telling, I was hit very hard. And I will put you in context. It was not the bad weather that has been here all these almost 2 weeks in a row. That's a very minor problem, and I will tell you what's happening because it hurts the channel and myself. What happened is, I'm on Portal 5. By the way, we are streaming from here. Planet Earth, continent Europe, country Portugal, region Algarve, 37 latitude, Portal 5. Well, Portal 5. God, I'm trying to assimilate all these days. My brain, I need more time to assimilate this. Very hard. Well, I used to have, on my Portal 5, I used to have a Portal 5, a low Portal 5, Portal 5 almost 4, after I managed with a politician, a local politician, a very good person. I asked him, and he took the LED light that I had here in front of my house, and since then I have a good Portal 5. A few days ago, at the evening, I was, as you all do for sure, every night after dinner, I was watching to see if the clouds were gone and I could make something with a telescope. And I did like this, and I saw a big light here in my observatory, and I thought, what's happening? Could be some tourists, because now they are arriving, it's summer. Some tourists, they stop to watch a map or something, or to make a phone call. Some cars pointing with the lights. And I was outside, I was outside to check what's happening, and I got like, you know that feeling that you feel like ice? Like ice. I should be with the skin all white at that moment, because I saw not one, not two, but I counted already around 25 LEDs. 25 LEDs around my house, near my house. The only good thing is at the west side, so they are all for the west, which is a position of the sky that I don't point towards. But they cover like this. This is my side, my good side, the east side, from north to south. And now I have 25 LEDs all around from the west until the north. It's horrible. And they are super high, and they are super bright, and they are super white, much worse than the one that I had here in front of my house. And I was very scared. I was scared, and some nights ago, I have to tell this to you to move on. Then we move on, and I'm adapting. A few nights ago, I could have a quick opportunity, and I was with a telescope outside with clouds waiting, because I was anxious to know what's happening with my sky now. But fortunately, I posted, you saw, some of you, a very nice picture I will show you. A very nice picture. Not post. Well, it was post-processed, but not so much. Only with neat image to clean the noise. And it was with a king. It was my first Eagle Nebula. It was with a king, and it was with a new filter I have, a narrowband filter. You see, it's a beautiful image. It was a bit of clouds, but at this moment it was good, and it was a relief. Really, this image, you can't imagine how I was relieved to know that I still can do a good imaging session, watch the sky live stacking, even with all those LED lights. The thing is, I can't do anything about those lights. They belong to a huge multinational, and the guys are horrible. It's not a local stuff that I can deal with good people. No, they can't do anything. Besides, they have not a good relationship with them here in my city, my town. So I'm done with that. What the humans do when we are hit so hard, when life does things like this to our astronomy, well, we adapt. We adapt ourselves, and it's what I've been doing. From one side, I'm adapting my brain, which is very important, my mind, because I was very down when I saw this. And I'm adapting the things. Now, I usually have the king right here. You can see the king usually right over this door here. Now I change the position to a place that doesn't, at least is not hit by the straight light from the LEDs. So it was this picture was took from that position. And all these days, to calm down my mind, I was also improving the setup, especially the king. I placed this for the people that has the large Dobsonians, or even not so large. I wanted to improve the stability of this Dobsonian over the equatorial platform. For the ones that have equatorial platform, this is a very nice hack. Actually, there are two hacks. I placed more Teflon. This is a trick. I will tell you. It's physics. Let me show you. This is very important for you to have ideas. To have ideas about what you can do to improve your Dobsonians. Any Dobsonian. I'm waiting a bit for the nebulae to show up in the sky. They are still low also. Let me see if I can show you. This is a very good hack. Well, no. Hold on. The music. This was a stack of 40, this was half an hour, with only 4-second exposures. 4-second exposures. I repeat, 4-second exposures. Only. I think I don't have it here, but I can show you I have an image, but the thing is, the Dobsonians here, with this, there are two kind of clutches, of bearings, altitude bearings. The bearings, I think, is this. These bearings, let's call them bearings to simplify. These ones and the ones that I have in the 8-inch Dobsonian, the new one, it's a new system. This is a new system. Most of you, or many of you, have this system, you see, with these clutches. These kind of clutches have an advantage. If you tighten them very well, they will help you with the balance. However, if you want to move, you have to untight. And the thing is, some people, many people actually, suffer from backlash. If I usually you leave the telescope as is and you move a bit the tube, and it has backlash. It has a space. There's a trick. The trick is to find, this will be your feeling only, an experience. To find the right position. There's a right position here, not too tight and not too untight. Okay? Not too loosen. There's a balance, a sweet spot where you tight both of the clutches here, and it will not provide backlash. But it's very hard. You have to do that in a way that you have to feel it. Then there's here, you can change the position here of the Dobsonian, up and down. Here you have to take this off and adjust. It's easy thing to do. Up and down to get the right balance. It's a good thing to do with some things here in an imaging train or optical train, like eyepieces, heavy eyepieces, because usually we need to balance to avoid all this weight at the top. Okay? So this is one system. This is an older system from GSO, Guangcheng Optical. And I don't know what I prefer. I think I prefer this one because it's much simpler. We just have the roller bearing here over the rocker, which rolls, and then we adjust the strength here with a spring. You can use the spring without these things here, these rings, but I have them to adjust the intensity. Okay? If I want more strength, I pull them down even more. Now, this helps being stiff. This helps with the balance also. And the balance is a problem with the 12-inch that I have outside, especially in the night, as tonight, which has loads of wind, and it's very sensitive because it's a large Dobsonian, this telescope. So we might help that situation using this. And also this. These small things, white things that you see here are 2 squares of Teflon. The Teflon, it's here for a reason, for this to run smooth, okay, without touching the wood. Now, the thing is, and the physics I told you, is this one. This is an old picture, it has only 2. Now I have more. I'll tell you. The more you apart these 2, these are at a certain angle. If I pull them down, for instance, both of them, it will run more freely, more easily, which I don't want. I want stiffness. So to get stiffness, we can move them up in a a different angle. Astrothi, thank you for your support, for your super chat.
Thank you.
Super shot.
Thank you, Astrothi. You're always a good supporter. Let me pull the message for the world. Always cool to see you talking about Dobs. The teacher, the master, the Dob father. Well, I'm just a passionate about the Dobs, as you know. And by the way, this channel will be much more focused in the core, in the Dobs, in watching the sky in real time, and all the rest. I'm sorry for the people that might not like that, but astrophotography is not a business here. So, but we have many more stuff coming. I will not tell anything. I will shut my mouth. But I have more plans, and you will like it for sure. I know. So thank you very much. Now, this is more than talking about Dobs. Look, this was a way that I use to heal myself from being in a bad space. I was really in a bad space. I was shocked with this. The first thing that came to my mind, and it's not an option, but the first thing that came to my mind to see how it shocked me was I have to move house. I have to move from home. And it's very hard because this home is so comfortable and we built it. We built this home. It was almost from scratch. And it's very, very personalized and customized and in a very good place. It's very hard for us to move to a better place without paying a lot of money. But that was the first thing that came to my mind. And this that I'm showing to you was what I did, and you should do the same because it's a good therapy. Improving my Dobs to adapt my brain to this new situation. So, if we move them up, more stiffness. If we move them down, more loosen it will be, and it will be harder to balance. So, what I thought was, and if I never saw anyone doing this, but I thought, I have Teflon here. I will show you. This is Teflon. You can buy it. This is I think it's 2 or 3 millimeters Teflon. The equatorial platform has a larger one. But this Teflon, it's very easy to... It's not too much expensive. And you can cut it easily. So I thought... And if I had, instead of moving them, I will keep these as is. And instead of that, if I add 2 more and 2 additional Teflon, and I did that. I placed here 2 additional squares of Teflon, and this is much stiffer now. So this was one thing that is outside and is a stress test that I'm going to do tonight with the wind because it's super windy. So I have 4 Teflon tape here, Teflon squares each side. I did in the other side. Simple as that, very easy to do. You just have to be careful because I used, how to say in English, hold on. I used nails. I used nails. 1 nail in one side and 1 nail in the other side. But to avoid scratching, we don't want the nail to touch the wheel here, the bearing. And I use this. I use this blade, you see, to do like a bit of a hole just for the head of the nail to be below the surface. And that's it. That's enough. No scratches. So this was one thing. And the other thing I did was, this is more for the people that has equatorial platforms. The other thing I did was, oh, I should have here the pictures, but I don't, it doesn't matter. I can show you like this. Hold on. Where is my equatorial platform? Here. This is the equatorial platform I have. Now, one thing for people that has equatorial platform, that will have, or that will build an equatorial platform, it's very important. This has 1, 2 at the south here, 2 roller bearings, and 2 here at the front, at the north. Here is the motor and a band, which moves this shaft to track the sky. So it has 4 points of support. What I did was, because I know it's important to have the Dob over the legs of the platform. Did you notice that your Dobsonian, your Dobsonian legs, any Dobsonian, these legs, if you open this, the rocker, you will see Teflon, or a Lazy Susan, or both, or something, usually Teflon. Did you notice that the Teflon is over the legs of the Dobsonian? The Teflon is at the same position of the legs. And why is that? Because the strength will come here directly to the ground. If the Teflon is in the inner part of the circle, of the base, the force will be like this, and then go to the right, and then go to the ground. But as it is right over the legs, it will go straight on vertical. It's gravity. It's the gravity. And I noticed that, nobody told me this, but I noticed that these legs are more or less below the points of this Teflon, where the Dobsonian rocker touch. This and this. But this one is over the roller bearings. It's okay. So this is fine also here. Okay. We'll go right away to the telescope. Don't worry, because I'm waiting for the nebulae to go up. You see? Here the bearings, another shaft to move the south without motors, and here the Teflon. But the legs are here in this platform, and in other platforms are here. And I understand why, because as this moves back and forth, they couldn't insert the legs here. Well, I did it, because I have my latitude. If I change my home one day, I don't know the future, I can just take off the legs. So I drilled. I drill here below the bearings, 1, 2, and move the legs from here, the 2 legs, to here. And it's much, much more stable. So now let's do the test. So for people that has equatorial platforms are going to build, remember that the better you can do is to have it the legs below, and it's more stable because it will not shake so much. Right, Brian, Ebony Star. Yeah, Ozzy. The tent is a problem. I tell you what, I have a project in the town hall. It's waiting for approval to rise my walls. That will solve the problem of the straight light. That will solve. And the wind. It will solve that. But I'm waiting. Meanwhile, I thought my wife actually gave that suggestion also. But meanwhile, I can't have things here. First, remember the Dobsonian. Look. The ones that have Dobsonians know this. Know this, especially if you like to point low in the sky. If you can't point low in the sky, I understand that you don't have this problem. But if you want to point the telescope like this, how can I have a wall here? Tell me. You see the problem? The only way I can have the wall is having a double wall. So something that covers everything and then it falls to the front. And then I can have just the wall here. But that will not protect too much from the wind. What really will protect from the wind will be the big wall here. The straight light, I can deal with it meanwhile with a tarp. I used to have a tarp. It's not very comfortable because I have to take it off and put it on. It can't be there permanently because of the wind, the strong wind. But it's a poor solution meanwhile. But what I did was to place here the telescope. I'm changing, I'm reassembling, I'm resetting everything, rearranging everything here to have the cables not from here that I usually have, and like now I have the cable that goes from my laptop there, outside, and there, 8 meters, remember, 8 meters, there to my telescope, the King.
The King.
By the way, it has a new sticker, 2 stickers, the King. With a king. I will show you later. Okay. Pointing in horizontal, for instance, I have a good view from south. I still have, thankfully. And like the Omega cluster, it's low in the Omega Centaurus. It's low in the sky, 8 degrees. And I go against the rules. I don't wait for 30 degrees to watch an object. That will not be a 30 degrees. I point the telescope down and wherever it comes. I'm up. Afraid. I'm in the first floor. Open. This is all open. We have no buildings here. So the wind, and here the wind is strong. I can't have a screen permanently. I can have it just for a while. I will put the tarp. Hey, Anaximandros, Samir. Samir is in the house. Samir, one thing that about your business. Then you tell me, because maybe I can help you to give you information about the guy. I don't want to give it here. If the budget is a problem for you, because I didn't ask that, the budget, it's important, the budget. Yes, I was drilling a lot. You love the 8-inch. No, not more crispy if you have a bad thing. And if you have a 6-inch or 5-inch, will be more crispy because you don't have the good thing. But with a good thing, the 12-inch and larger apertures. Thank you, Quasar, for gifting 5 Dobsonian Power memberships.
Thank you.
Armando, James Dogan, Sergio, Roman, David, you are now members of the Dobsonian Power membership. Let's go to the business. I'm trying to release all of this energy, this anger that I have inside about this stuff. And now I think I can move on. Because there are more problems here. This was the huge one, but there are more problems. One. Let me check the weather first. So the picture was a relief, basically. With a king. Let me check the weather. I predict that maybe only about 1 o'clock will be with clouds. See, not bad the forecast now. So you can count with me. Let me check. Yes, these clouds here, you see, will take a while to arrive here. So meanwhile, we can move on. More things. I tried that night with that picture, that only moment that I had with the picture, I couldn't plate solve. I couldn't use the push 2 with a sharp cap, which is a great feature. I talked with Robin in Sharp Cap Forum. He said it probably was the sigma of the stars. Okay, the configuration I have. I bet it was because it was a cloudy night. This picture, this wonderful picture of the Eagle Nebula, was with the king in an awful night, within the clouds. And it was, you know that the eagle is in front of the Milky Way arm, so it has loads of stuff there, loads of stars, and they are blown up. So I suspect it was that. We will try that right now. Stress test, first, to the king. First, with the balance, with the wind. If it can hang on the wind that is here now, it's about 30 kilometers, I think. It's very strong. In this new position, good. It is polar aligned. I did that job these nights because the Polaris I couldn't see very well, but it's enough even with clouds to see something to polar align. So, balance, first challenge. Then, sharp cap, the push 2. If it doesn't work, not only the push 2 feature that he has, the plate solving. Plate solve is to the sharp cap watch the image in the sky where the telescope is pointing towards, and he can figure where it is, but it's not working. Even with Solarium, the old push 2 that I have, not working. Something's happening. And I had to find that Eagle Nebula with the eyes, with a finder scope, old-fashioned way, which is very nice to do sometimes. And it was easy. To be fair, it's very easy to find it. So if it doesn't work, I will find it with this or another one. Maybe another thing. I have the Bader Neodymium. I have a new drawer, so I can change the filters easily. This will be excellent for the live streams. Okay, let's first open SharpCap. And just one more thing. Thank you for being loyal to this community, for being part of it. You talk a lot with me. on Discord. Join us on Discord, by the way. And you are great, great. And I always said less sometimes less is better, and I enjoy this community. Okay, Sharp Cap. I'm using the new beta version of Sharp Cap. Let's connect the camera. I don't have the cable yet. And the platform. So first, camera and platform. Now, I'm a bit nervous about this, I can hide, because the Eagle Nebula was at south, and south is my best view. The LEDs are here at north and west. So I will point now, maybe to the Crescent Nebula is a bit upper than the Eagle and those nebulae. And it will be closer to the light effects, but I have to stress test this. Let me see the position in the sky first before connecting the camera. The platform is already connected. We see with Stellarium. So the Crescent, well, we could try even a worst one. The Iris, I can't see from this position. I almost can't see Polaris. Polaris is cut by the wall. I can see, but it's distorted. I can see with only a part of the tube. The Iris, I think I can. Well, it will be a good test. I have the Badr Neodymium. It works for this nebula. And then we can try the Crescent with a new filter, the narrow band, the quad band. If I can see the Iris, the LED is here, start here. Okay. Position in the sky, 68, it's a good position. No, 35. Altitude, 35. It's not so high, but it's enough. $11.8 my 224. Yeah, I get the feeling. I have the same feeling. I will use the 224 for other stuff. Yes, AstroTiv, right that. The east and south is where the magic happens. I always point there. Okay, I will point to Iris to stress test this. Let me see if I can see the stars. I forgot that because now it's tough and I don't know if the push 2 will work. Where's my camera? Camera is gone. Camera is gone. I think it's the heat of the. I have a backup. You can try this with a 224 or other camera. This is a cooler. It has the exact measure. Look, 224. This is as a magnet here. You can place it here. You can try. I never tried because. And you connect the USB and it will cool down. I never tried because it has a problem. After a while it gets with some drops of water, of moisture here. But you can try. Let me connect this to the camera. I think it's working. No, it's not a strong magnet. No, I don't think so. The magnets I have in my purse, in the Dobsonian, maybe, because it's 2 kilograms, but not the. This is a cheap thing in Amazon. I bought to cool down, now that it's too hot here, to cool down the smartphone. Gets super hot with the camera. Everything here. Now let's see if I can see the Cepheus cluster. I will connect the camera first. Because I have to focus. Yeah, fingers crossed. I need to do this. Look at the background, horrible. It's different. It's different. Look, a new AP. I will point to a bright star first and try to focus it to see if everything is okay. Look at this, all blown. Well, the weather is not perfect. That doesn't help. But I think this is focused. The stars are blown by the atmosphere and the LEDs and everything, light pollution. Let me see. I'm using the remote that I have to try to focus. Oh, it was focused. It was focused. This is focused now. It's really a problem with light pollution and the atmosphere. Look. You see, it's not so black as it should be. It's a bit grainy, you see. Well, it isn't Aries. Well, it isn't Aries. It has the nebula. Okay, I will pass that. Maybe it's not so bad. Now, Cepheus. Polaris. Okay. Let's stretch this. And do like this. And while I'm outside, yes, I think I can see it. I think I can see it. Not all the stars, but I think I can see the triangle. I don't know if it's the triangle or here. I will see. So I have to point the tail rod here. Okay. Okay, I got it. Without any push too. Now the test. Well, at least we can see it. I think the filter, the Baader neodymium, is doing a good job. I think it's doing a good job. Okay. Let's see what happened with the Iris Nebula. For seconds, because of the wind. You see, this is much more stable. Okay, the wind is strong, but this is much more stable. And doing like this, a stiffer Dobsonian, it's easier to point. It's not so smooth to visual observation as we are used to, but to get it stable for live stacking, to do EAA, it's much better. It's stiffer, but it holds better and helps with the balance. Let's do the live stack. Watch this beauty. 4 seconds. It's enough. I'm using the Baader neodymium filter and the camera is the ZW0294. This is the stress test. If it works with this nebula, it will work with all the others, because this is the closest nebula that I have to the first LED lights. Okay, let's do the tricky with the histogram. Yes, a bit of gradient. You see the light pollution. Much more gradient here. Much more noisy. Let's see what happened. Yeah, the difference we can notice here in the background. I was heated hard, for sure. But something, this will be the worst scenario, so that's why I wanted to stress test this tonight. This is the worst scenario. If it works, and it works, if we crop, the gradient goes away. Unfortunately, this part of the nebula, I'm curious to know, to see if this part of the nebula can pop on the screen, because this is a beautiful nebula. I have to change the setup with the cooler. This will fall. You doubt that if we will outlive our own stupidity as a species? Me too, but I want to believe that with the fusion with the machines in the future, artificial intelligence, everything, will help us to get there. Maybe they get smarter than us. This is not working, this. You see the cooler? You see the water? With a smartphone, no problem. You see? You see the water? It starts to form. While my mini cooler in the ZWO, I forgot to connect it. I will. It works without any... No, I can't use it. The mini cooler I have in the ZW294, I have a video about it. If you want to do something similar, it works. If you aim the DIY project without being greedy, without wanting to have many degrees lowered, I aim to just 5 degrees lower, and it holds very well. I'm using it for a long time with success. I forgot to test the push to. We will test now. You see the histogram. Well, it's not so good as it was before, without the light pollution that I have now. I think now I'm a 5, close to 6. It depends on the part of the sky. More 5 in the south and more 6 in the north, like this. We can see the washed sky. Look. Look. You see? Here and here. All over the place. Now, let's do some enhancement here. They have a good enhancement here. The unsharp mask. And let's see the color noise reduction, what it does. Yeah, it worked fine here. And maybe I have to use, look at this. What a shame, the light pollution. Maybe I can't use the narrowband filter here because this is not an emission nebula. It's a reflection nebula, which means these stars, the nebula is reflecting the light of the stars. This dust is reflecting. It's not emitting. And that's why the narrowband filter doesn't work here. The Bader neodymium works. One of two. To upgrade to Optalong L Pro, which is a bit harder, to this part of the sky, or try, and I can try right now, the gradient removal from Sharp Cap. Hey, whole bunch. Whole bunch is in the house. Yes, it looks like the iris ray. What? Rao. It's more than a paradox, Fermi paradox. It's us. Trust reality. Space is out of understanding. Rare, void, and great. True reality. I have your link here to show to the people. It's pending, Rao. You can participate in that. I have a section here which is the breaking news, where I bring not only news but interesting curiosities in the live streams from NASA, things that are important and interesting, and you can post them on Discord if you are a member. And if it's very important and you can't post, you just tell me there, and you can send me the link. Yeah, it's dealing with the wind. Tonight is the worst scenario that I can have with the 12-inch Dobsonian, with my telescopes. The wind, the worst telescope for the wind is a 12-inch. The light pollution is, the worst position is this one, pointing north. And you can see that it damaged a lot the views here. Now, I will try now, right now, I will reset the live stream using the gradient removal tool to see if it works. I never need it, but now I need. Now I'm a poor guy again with light pollution. They have two now. Linear gradient removal. Let's try this one. Let's reset this and see what happens. It will move the histogram. Look, a new AP. Bam! Photobombed. Let's clear again. It moved the histogram. That's why it's so bright. And we adjust. We adjust it. Color and stretch. Well, it worked. Guys, it worked. If you have the same... well, at least it seems to work. The background is much more even. You see, it has not... Samir, if you are watching or listening, this is important with your problems with the gradient. I know you tested already. Maybe you can do some flats. I'm using flats also, but it's appearing again. It works well for you, Ray. Really? I use the average one. Okay, I will use it. Let's just wait some more frames. Oh, thankfully we have solutions for everything. Yes. Yes, Samir. I'm back to the poor guys again. I don't have a car anymore. I just have to walk. And but you know what? I'm still happy to be here with you and to be watching, to be allowed to watch the sky despite all of this mess. But it's working, the gradient, it works. Not so good as I expected because I can still see some, but it works something. Let's try the ray suggestion, the other one. So it was only 64 seconds. Hold on. Because this is ignoring with the wind. But look, the stars, very nice. This improvement I made, this is all about this. This is all about compromise, about commitment with the Dobsonian. Well, with any telescope, actually. But in this case, with the Dobsonian. The commitment with the Dobsonian made me using the Dobsonian to surpass the bad feelings and to improve the performance of the telescope. And that brings me again slowly the happiness. The brain is resetting, is assimilating, and we will be fine. We will be fine. Well, not so much here, but it's better than without it. Let's try the ray suggestion. It's the non-linear gradient removal. Experimental, it says here. Okay, let's experiment. We have to select it and clear. I think we should. Wow. Of course, the histogram. Let's readjust the histogram. And bam, let's see. A burst of serotonin. Yeah, something like that. Well, it works not so good. This one, Ray, look at the borders here. The green here. At least for this situation. Well, they have different tools, should be for different situations. Now this one I didn't like. Let's try another one. They have here the low frequency wave, experimental. Okay, let's experiment. You see, you should do this kind of stuff if you have problems to figure it out. To figure it out, what you should do. Wow, the wind, look at this. The stars are not good because of the wind now. It arrived a strong wind now. And it's from north. Where we are pointing towards. Look at this. I will lower this. No, it's okay. Strong wind, strong wind. Okay, doesn't matter. I just want to see the gradient. What happens with the background here. So far, I prefer the first one that we used. The average background one. We will try every one of them. This one, I didn't like it also. Let's try now. It does have here blended, offset, and simple offset. Let's try blended. Clear. Maybe because this is the new version, Ray. I don't know. Maybe it changed the names. Could it be? This one... It's not bad, the background look. The problem will be here at the top. For you, Samir, non-linear removal. Okay, okay. We have to trial and error. I don't know, Overhead. I don't know the answer to that question. Yeah, Ray. That's because you have it well tight. If you manage well with the wind a 16 Dob, that's because you figure it out. Blended, okay, okay. I think this is doing a good job. Maybe we can just adjust the colors, because if we move the histogram, photobombed. Weird. Different directions, you see? You see it? Like this? What was that? It's still heavier, that thing. But the Nebula is still better, I think. Let's use the non-blended. Simple offset. I will have to use these tools, at least for this part of the sky. This is the wind. This is the wind. I'm not caring about it because I'm watching the background. I like this background. This is the blended. Simple offset. But I can't do what I usually do. Oh, I can. Yes, this one works better when I move the histogram. It still have, it can't, neither of them can remove this awful effect here of the light pollution here at the top of the image. But it's better than nothing. We have more. Remove satellite trails. I don't want that. Another one. Look at the trajectory. It's not straight. What a weird thing happening here. Could it be a harp? Look at the... Are you watching it? Look at the trajectory of this thing, this UAP. This is not a satellite with this trajectory. It could be the wind. It could be the wind. Shaking the telescope, okay. You are on 7/8, Ray. That's tough. Yes, this is the wind. This is the wind. No, this was the wind, for sure. Now let's point to the Crescent Nebula. It's upper now in the sky. As it is so windy, well, I will try to get a last shot here. Now the stars are fine. Let's see if it holds on with the simple offset. This is a simple offset. I like this background, you see? Let's lower the filter here to 7. And see what happened. They don't blur because I have the filter here overhead. I have a filter, you see, when they blur, when the telescope shake, the software identifies and cuts, like now. You see, it's rejecting all the frames. Look at these red frames. Our bad frames are being rejected. It takes more time to watch the same image, but it avoids that problem. You see? The stars are round because he just didn't accept those bad frames, and now he's accepting the good ones. As it is so windy, more than a half of the frames are being rejected. Well, actually now it's stabilizing. When you saw the satellite moving, the stars were elongated. I saw. Maybe you can't see very well because you are not zooming in the image, but I can see from closer to you, or closer than you. Yeah, Samir. Well, at the end, the important thing is to apply them and see what happens. Even that he can explain. I don't know if he did it, but if we ask, he explain. You think? You lost the color? The first image. It's a bit noisy. It's a bit noisy. I will use no filter here of noise reduction because, well, I can use. Maybe that's the problem, the color noise reduction. I will use this one instead. Iris Nebula. No, it's not Coma. I don't have Coma. I use the Arizona Nexus. Iris Nebula. You see, while many of the nebulae visible in the night sky are emission nebulae, clouds of dust and gas that are hot enough to emit their own radiation and light, this nebula, the Iris Nebula, is a reflection nebula. This means that its color comes from the scattered light of its central star, which lies nestled in the abundant star fields of the constellation Cepheus, 1400 light years away from Earth. It glows gaseous petals stretch roughly 6 light years across. This is from NASA. It is beautiful. Short exposure, yes, but I can't increase the exposures because of the wind. But usually I can't even do for 4 seconds, so I take it. Now I wanted to show you something. And this is the breaking news.
Breaking news.
This is a segment of these live streams where we not only talk about news but also interesting things and facts of the universe. This was the short I did and I uploaded. It's about this. This is a NASA work. Some of you may remember. Some of you may remember that I showed here similar work these guys have done with a mosaic with loads of galaxies. This is the image, the last image from the deep sky from James Webb Space Telescope. I will open in another. I will open the image because I have it. So look at this beauty. This has more than 45,000 galaxies. 45,000 galaxies here. Every single dot that you see, almost every single dot that you see here, are galaxies. Guys, this is amazing. Can you imagine how many planet Earth like planets here can the universe have? Look at this. I will zoom it a bit. They have on that site, and you can download, if you like this kind of stuff, you can download the full resolution image. This is not a full resolution image, but it's, look at this, with gravitational lens here. This is James Webb again, evolving, improving, and providing us. Look at this, look at this beauty. This cluster of galaxies here. Incredible. This telescope will give us, this is a star, but the stars are rare. This is a star. Almost all the objects are galaxies, even the faint ones. Look at this, another cluster so far away. This is amazing. And it goes, it's super large, the image. Incredible, isn't it? James Webb. They are doing a very, very, very nice job with this tool that humans have. And I bet I'm anxious to see. Look at this, looks like a crown of galaxies here. I'm anxious to see if they can find even more amazing things that can reveal amazing things in the universe that we don't know yet. 45,000 galaxies in this image. More than, they said, NASA said, more than 45,000 galaxies here. I wanted to show you because usually we don't have time to stop and look at this amazing news. Let's see how it goes. Look at this light pollution. I can see, I can predict that every time I point a telescope to this part of the sky, I will have to crop the image. I will never ever have again the Iris Nebula as I had last year, for instance. It's sad. It's sad. But it's the reality. 45,000 raw, yeah. It's amazing. It's amazing what these guys are doing with the James Webb. And I don't know how to do that, but many people are using the data from James Webb to process the images. And they are discovering, they are adding to that knowledge in science, processing those images. That is good astrophotography. My opinion. Let's point to the Crescent Nebula to see how it goes. I have to do it. I'm very curious. I bet that it will be not so hard here, but we'll have the glow at from the city. I don't know. I will reset the platform and point there. Let me see Stellarium. It's easy. It's easy to point. Cygnus. Here we have this cross here. And the crescent is... Where's the crescent? Here. So it's a Telrad almost to the star, the central star, Sadr. It's easy. Let's see what I can do. Let me try the push to if it's working. I don't know if with the wind. I almost forgot. So push to. Search. Crescent. Crescent. Start. Let's see if he can plate solve. This is moving a lot. He played solved. Look, even with the wind. So the problem I had was not the software, was the sky with clouds. He played solve and he says here, left 0.35 and up 0.63. It's almost there. It's yellow. Yellow means almost there. Now I will move the telescope. It's with a lot of wind. This is only is still plate solving. Look, it's working. I will move the telescope as he said here. If it's far away, it will be red, but it's close, it's yellow until it gets green. It's working, the plate solving. Yes. It's super windy. Look, the crescent is there. Let me see if it plate solve. It's super windy. I can't have a good view of the crescent. Look at the wind. But at least to see if it works. The crescent is here at the here. Now it didn't. It's trying again. Now it's stabilizing. Let's see if he can. Yes, he could. You see, it's starting to get green, the image here. This is amazing. This is an amazing tool. Thank you, Robin, so much. I will tell you right away. I will answer the post in the topic I did because I was not managing to work. I will tell him right after the stream. I will tell him that it worked fine. Now I suppose this, the nebula is here. I suppose that if I center now, it will be even greenier. If I center this, it will be fully green. Let me see. This is a great feature. Where is it? It's not here. It's not working because it's not here. It's shaking a lot. It's too much wind. Now it's very strong. This was this stream and it was intentional. Sorry, but I had to do it. It was to work with the extreme situations that I have, the worst situations, and to see my thresholds. But the weather will be better now. The forecast is good. I think it's at the top, yes. Okay, I will do it again. Push to assistant. Eagle. This is very easy to use, you see. Eagle. Select. It's here. And start. And that's it. Now it will plate solve. It's on not yet known. It's trying to plate solve. And it's not... I didn't close the previous plate solve. I think it can be that. I'm not sure. Let me close everything. Stop. When we stop, he has to fix this. He's still plate solving. He keeps plate solving. Let's do it again. Push 2. The nebula is here at the top. It's cut. It's cropped. I write here. So here, search. Eagle. Very nice. Eagle. Start. It's too much wind. It should be that it's messing with the plate solve feature. Because it worked before. You saw it working. You see, it's moving a lot. Look at the stars now. It is the crescent. It is Ray. Yes, it continues, but it should stop. After we close this, it was supposed to stop, I told Robin. But now he didn't play it solve again. I don't know why. If it's the wind, because the first attempt, it worked fine. I think it's because of the wind. I said eagle. No. Mistake. My mistake. It's a crescent. I was with the eagle in my mind. The Eagle Nebula. Of course, the eagle, it's not here. That's why. It's so far away that he can't. Let's do the crescent. It may be that, Ray. Crescent. Start. Let's see now. Because it has to be near the nebula. Let's see. But it's not solving again. Let me stop. Start again. Crescent. Start. Oh yeah, Ray. Good to know. I think the wind may affect, yes. Because the first time it was working. It's very strong, the wind now. Very, very strong. Let's see if it works. But at least it worked. I will tell Robin. I will report everything that I'm doing here to Robin to help him, because this is an experimental feature. It works fine, but I think it's sensitive to the wind. It should be. I will try another thing. I will try to point it. This is impossible. It's to northeast. I will try to south, because it has not so much impact, the wind, and see if it works. The crescent will be another day without wind. It has to be without wind. Let me see. Stellar. You see, we close this and this keeps solving. It was not supposed to keep still solving. Let's see what we have here at south. We have already the eagle. It's at 31. So, Ophiuchus, then this star, it's easy to find, then 1, 2, we have another one here that I think I can see, and it's down here. I think I will do it with a... well, I will try the push to first. Hold on. Manual push to. I will do the old-fashioned...
Start hoping.
It's so sad I can't see the stars I'm used to see so well. But it still affects the wind. Well, let me try. Push to assistant. Search. Now it's eagle. Eagle. Start. With the eagle it didn't work the last time I did it. I don't know if it's the... if it was the clouds or... now it worked. Now it worked. Left 7 degrees, up just 1 degree. Let's do that. Amazing. I moved up. Let's see what happened. It's solved. 1.3 degrees. Okay. Now I moved left. Let's see what happened. From 7.5. Come on. It didn't solve. Gives error. Oh, it solved. From 7.5 to 3.99. Okay. A bit more. I moved left. You see what you can do with your Dobsonian? Without a go-to. 2.06. It's working. Oh god, it's working. A bit more to the left. I asked him to shrink this box with a collapsible menu, but he didn't yet. .94 and down 0.14. It's almost there. I moved left again. It's there already, look. It's there. It's working fine. And there's a trick that I just found. Now it failed, but it's trying again. This is amazing. Let's see. Because this is a area of the sky full of stuff. It should be harder. Left 0.28, down 0.21. Okay. I'm watching here below the colors. I just want to watch here, left and down. It's what matters. Now I know because I'm watching the Nebula, of course, but it's only to test it. It's there. Let's see what happens when it solves. This is an amazing tool, guys. For Dobs, We can be outside. Look, it's green now. It says right 0.04 degrees, up 0.04 degrees. So it's enough. Distance to target 0.06 here at the green. When it's green, it's fine. It works. It works. Now I close here. And I close here. Where is it? It's here. Cancel. I don't want it to keep plate solving. And now I will try to live stack, but even at south with this wind. But as I am here, I will try anyway. Because I'm trying now without the quad band filter. I'm using the Bader new dimming. And I wanted to see the difference. Clear. If I can keep it stable with this wind, it's a very strong wind now. I think it will be until 4 o'clock in the morning like this, so I will lower the filter here. 6.5. And see what happened. And see the difference with the narrowband filter I used. I think the background is straight away I can see the background is different. Okay, now it's good. The background with the other filter, the narrowband, was a bit darker. And now adjust the histogram. Yeah, it's a bit more noisy. But the colors, I think they are better. Let's see what happened. But it was a long live stream, live stacking. The other one, it's working. Another stress test that passed. The filter, the Bader new dimming, at least to the south. You see, we have no gradient now because we are pointing in the opposite side, towards the opposite side of the LED lights. Yes, I saw Ray. Most atmosphere, of course. But at the end, let me clear this. At the end, the tests I did tonight, well, the wind, even with a better balanced Dob, 12-inch, the wind is always the wind. And you know that, Ray. With the Dobs and large instruments that we can't protect very well. Let me lower the filter even more to 6. 6. Okay, 6 is fine. You see, I found the balance with the filter here, the full width of maximum, to reject the frames, and the only ones that it keeps are the good frames. But they are really good because the stars are fine, so we find the balance. Am I using the gradient? Yes, I'm using the simple offset. Let's take this off to see if to south I need. Well, the simple offset now worked fine. Let's see without any background removal. See what happened to the background. Another test. It's rejecting, it's coming the wind now. It's very annoying, but it's what we have. Look at this, the wind. I have to adjust the histogram also because I removed the tool. And I just adjust this. Yes, it's more white. Well, we can move this. But I prefer, Ray, without anything, without those gradient removal tools, because I can see straight away, without anything, some parts of the nebulosity here around, not this one at the core, the outer edges. Look here, you see, we can see some faint nebulosity that with a stack will pop if the wind allows. I prefer, you see now it's stacking, and it will help to pop faster. So if we can avoid, it's my conclusion, if we can avoid that gradient removal and only use it when it's really needed, like the one before, the Iris Nebula near the LEDs, then we pull the trigger. But if we don't need it, we shouldn't use it. Now I'm using the Baader Neodymium. The last picture I took was this one. And it was with the... let me pull the original one, not processive, because it's very different. Not processed, with a narrow band, the quad band filter. It's different. You'll see. The quad band filter, this is not processive. Nothing. This is original live stacking. The narrow band filter pulls more detail. Maybe. I don't know. But it yes, it pulls more detail of the hydrogen. And the background, look how black it is. The background. And much less noise. It's the big difference I can see right now. Let me adjust the histogram. The noise is important, but it's only 52 seconds also. You know what? I think my sky likes more, my telescope with my sky prefer, my Bortle 5, prefer the Baader Neodymium. The quad band will be to the moon. Looks great, no, Ray? Yeah, the Go. This is a great tool also for go-to telescopes, because it because that, Marco, because it can be a backup tool, a plan B that we have on hands, easy to use. It's very fast. You saw, it's just the menu and bam, write the nebula, even that you don't remember the NEC 2000 or whatever. You write the name of the nebula and it pops right away. You select, bam, start. And it will help you to adjust the push to, the go-to. Nice idea. And one thing that I like, that the narrow band filters, all the narrow band cut, and these softer filters like the Baader Neodymium, the Optolong, the broadband filters don't cut, and that I like. It's that bluish glow that we see. That's why the Iris Nebula, it's better with those filters. The colors, okay, it enhance. Here at the right we have the quad band. It's true, it enhances the nebula. Hold on, I have, this is half an hour, but I have images, previews with less stack. Let me see what I have here. I have here, so we have already 20 stacked. I have here 88. Let's see. But the narrow band filters needs stack, needs more stack. You see, with 88 frames. Now we have 20 here. Here we have 20 with a bad neodymium, and this at the right with the narrow band filter. It's a soft narrow band. If you use an extreme narrow band, it will enhance more, but it will cut more light also. Enhance is the H alpha, yes. Yeah, I have better skies. But you know what? I was used to something better all this time. And now I feel bad about it. Because if you can improve yours, it will give you a boost of happiness. If suddenly it improves for some reason, some LEDs that they change or something. Yes, narrow band takes longer, it's true, Ray. That's why I had to be with half an hour to get a good image on the screen. Less noisy. It's less noisy, look. This one with the neodymium, it's more noisy, but we can deal with that. Let me see here. Enhancement. I'm dealing already. I have the filter applied. $23 stacked only, 77 ignored. Look, it's 80-20. 80 ignored, 20 accepted. That's the huge difference with the wind. Then we can move this. This is a beautiful, the eagle and the pillars of creation. Anyone knows the name? This has a name here. This part of the nebula has a special name because it's forming here something. Do you know? What is it? Unless you have a RASA, of course, at f2. Yeah, the NBZ, it's a good filter, yes. I opted by this one because I wanted the softer filter I could get in narrowband. Because despite the new LED invasion that I have, I still have good skies. No, yes, this is the pillars here. But here at the left, this here. This object here has a name, a special name. It starts here, and usually it's not easy to capture it with detail. The Dobs can do it. The Dobs can capture this detail here. It has a name, this, but I don't remember. And a story. It has a name and a story here. How's that, Offerhead? A real difference the neodymium makes? Can you get the same detail by changing the exposure of gain? What are you comparing with? It makes a huge difference with the neodymium and without the neodymium. Because without any filter. Because if I take off the filter, first the sky will get a bit pinkier. Because of the infrared, because the neodymium has infrared cut and ultraviolet. The stars, the same, and will get blown. At least with this kind of telescope. And the light pollution will pop more. It will be a less dark background. From there, according to your kind of portal or kind of sky, you may need to increase the aggressiveness of the filter until you reach, for instance, someone that lives in a Bortal 9 in the city. Usually it's easier to deal with narrow band because these soft filters, light pollution filters, soft ones, usually don't work well in those circumstances. Although there's people like Talal that is in our Discord server also, and it's a member of this community. He does a great job. You can see there in the community pictures, a great job with Immortal 9 with just a new HC filter. But remember that what he does is astrophotography, and that those skills matter. Once he showed us an image from the live stack and the difference that to the image after processing, it's huge. So that makes the difference. But in astrophotography, you can do anything you want. Anything. So the pure feeling is with the live image. We try to improve here the things to get, the goal is to get the true original live image the best we can on the screen. And that also will help people that like astrophotography, because at the end, all the frames that you save, if you want, all the frames that are stacked and that you save, Ray, I think it does that, will be better if you can improve like this. Or you can save those frames without any improvements also and use them in another astrophotography software. Usually if you have a good and powerful astrophotography software, usually you don't make these improvements on the screen, because usually you don't want to see anything on the screen. You want to see a posteriori. So you save without any improvements here in the live stacking, and then you do those improvements in the post-processing workflow. And you can do anything. Basically, today, you can do, if you invest in astrophotography, you can do anything. But through a path of manipulation of the image. It's the true. Depends on our goals. Now what I want is to have a good image here on the screen to watch. So that's my goal, to have a good background. I'm having a good background even with this filter, even with this wind. More noisy. You see the difference? How many frames? 42 only. It's more noisy. It will require more exposure time. No, overhead. The Baader neodymium is like an infrared ultraviolet filter on steroids. I mean, it does everything that the infrared ultraviolet filter does, but it also cuts a bit, just a bit, of other wavelengths of light pollution, but very soft. I'll show you. I'll show you the difference easily. Here. Where is it? The graph. Here. So, this is the graphic of the Baader neodymium. If it was infrared, the infrared cuts only from here to the right. So it's cutting the Baader neodymium. It does the same. And here, to the left, the ultraviolet. It's to the left, here. So this cut here, and this cut to the right is the same of the infrared. But notice that it cuts almost until the end here. These wavelengths here. That the infrared pass. Let's pass. The infrared let this band pass. So the infrared, the graphic, it's like this, all at the top here. It doesn't have these falls here, you see? This falls means pass. It lets pass here, a bit here, a bit here. It's an interesting filter, because it cuts just a bit here, a bit here. It's very effective with the light pollution from the old sodium and those kind of lights, street lights that we still have here. That glow, that yellowish glow in the horizon from the city, it's good on that. But as any filter, broadband filter, it's not any of them can do a great job with the LEDs, the white ones. But as they are mixed, and you see the glow of the city at the horizon, it helps to cut and to darken the background. Yes, it also cuts. Sorry, it also cuts a bit past the sodium line. Yes. Yes, I do the same, Ray. I save as scene, I clean later. Sometimes I do some tweaks just of the exposure to enhance something, or the color to adjust the color if needed. I usually don't touch the color. And that's it. Now I use the neat image because it's faster than the Topaz and it's not so aggressive. You should try it because it avoids that problem with the stars. Sometimes we have with the Topazi noise, because it only cleans the noise. It's not so aggressive, but you'll see this image. It's the only astrophotography I do. I will save as scene. Look at this noise. This is a good image. Look at this noise, you see? And with a neat image, we just open it. Well, I will open like this because I don't want so sharp cap. I go to the folder where I have the image. Okay, I pull the image. I pull the image here. This is the image. Look at the noise, you see? I just do this. Click here, auto profile. I select a part of the sky like this without a nebula. And click here, adjust and preview, and bam, it's done. It's done. It's already done. If I click, I see the noise, you see? This is the... Let me zoom. I think I can zoom. If I click, this is the original image. And this is the new one. And you can see, I will click again. You still have the details there. Doesn't mess. You see, filtered. This area is filtered. I just selected. You see, look. And it cleans all the noise, look. You see the difference? It cleans all this noise, look. And it's less aggressive than the Topazi noise. If you see, the stars are perfect. Are not distorted. Then you can play here with the sharpness. Actually, I forgot. Highest quality. And then we have the... well, this is stuff. Sharpening. If we enable sharpening. Okay. It sharpens the image a bit. And see, no artifacts, nothing. That's a myth that many people talk about. Then you save. Actually, I prefer just with the noise. Take the sharpening. Just with the denoise, like this. I will save it for the sake of having it. Saved. And then so we have many of them ignored. I suppose that it's the wind, still the wind. but at least I can see that we can make good stuff with a better neodymium. Although it has more noise. I will have to keep trying this on live streams. The weird thing about noise is at small image sizes it actually adds to the image detail. At large image scales it ruins the smoothness of the background. I use topaz denoise for macro photography. Ah, yes, for that it's very powerful, very powerful. I saw it working. Thanks, Rao. So beautiful Nebula with only 4 minutes. Here, I will save again. Let me adjust. Yeah, I don't know yet if I don't have to. No, it works. It works. The neodymium. I think it will work. We'll see. We'll see. We'll see if I need to something stronger or not. I want to avoid something stronger because the more you cut, the less light from the nebula you also have in broadband. People, community, thank you very much for being here, and we'll be with you next time with clear skies, don't worry. Thank you, and see you next time. Clear skies.